We know that the volume of a sphere is given by this formula. In this video, we're going to come up with a formula for this volume for a given h. I'm expecting you to know the disk method because we're going to use that to derive the formula for this. This here is easy to understand. So I've done a video to show the derivation of this formula by using the disk method. But here, in our case, we're going to try and integrate it from, remember our sphere has a radius of r, and this length here is h. So hang on. So this is part of our sphere here. So that's this solid here. H is from here to here. So we're going to integrate it from r minus h. So this is h here, that's this h here. So we're going to integrate it from here all the way to r. So the volume is approximately, for the time being, us summing up all these disks. So for given x, let's say x is here. For given x, we need to work out the height, and then we quickly pi r square it to get the disk, and then we times by delta x for the thin thickness of that disk, and then we're going to sum up all the disks. So let's start again here. For given x, we need to know the height. What is the height for this given x location? Well, the area of the equation of a circle is given by x squared plus y squared equals r squared. If you want to know the height, make y the subject. So square root r squared minus. So this here is the height of that disk. So we're going to get the height, which is this thing here. We're going to get the height. This is the height here, r squared minus x squared. And then we're going to, so once we know the height, we're going to quickly pi r square it to get the area of that disk. Pi r, because the height is the radius, and then we're going to square it. So pi r squared will give us the area of that disk, and then we're going to times it by a small thickness, delta x. And I'm expecting you to know this method because I need you to know the disk method. And then by using the fundamental theorem of calculus, we can jump to the volume equals to, because at the moment it's approximately you summing up all the disks. But when you have millions of these disks, when you take the limit as delta x tends to 0, you're going to have millions and billions of these disks. And then the approximation becomes precisely equal to. And then this summation will be the integral. And then pi, let's square, you're square rooting and then you're squaring it. So they will cancel each other out. And this, when you take the limit as delta x tends to 0, this delta x becomes dx. Now, I'm expecting you to be able to jump from here to here because we spent lots of time on understanding the fundamental theorem of calculus. That allows us to jump from here to here. And then now, this is a constant, so let's take it out. So that's a constant, so let's take out the pi. So now it's in front of the integral. And then it's just a matter of us integrating this. So this here is a constant because the radius of the sphere is set. So once you've given me the radius of a sphere, throughout the whole duration of this whole process, r, the radius of a sphere, is constant. Now it's like me asking you to integrate the number 9. When you integrate the number 9, it's just 9x. So when you integrate this, it will be, we're integrating it from here to here. So we're integrating it from r minus h. Hang on, let me just clean this up. We're integrating it from r minus h, and let me explain why. Hang on. So you've got your sphere here. We're trying to work out the volume of this solid here. The radius is r, and this length here is h. That's this height here. So this location here must be r minus h. So we're integrating it from r minus h to r, because we're summing up all these disks here. So we're doing it from r minus h to r. So now it's just a matter of us integrating this. So that will then become pi, let's integrate it now. Remember, r squared is a constant, so when you integrate it with respect to x, it will be r squared x. And then this would be minus, would be x to the power 3 over 3. From r minus h to r. So now let's evaluate this. Hang on. So we would put this into here and this into here, and then take away, put this into here, put this into here. So that would be v equals pi, and then let's put this into here. That would become r to the power 3. Take away, put this into here, it would be r to the power 3 over 3. And then you take away, now put this into here, put this into here. So take away r squared, and then when you put this into here, it will then become r minus h. And then take away, put this into here, that would be r minus h to the power 3 over 3. Close it off and close it off. So so put this into here and into here, that would give us this. Put this into here and into here, that will then give us this. It's just a matter of cleaning this messy thing up now. So cleaning it up, let me think. Cleaning this thing up, I'm going to visualize this as 3r cubed over 3. That is r cubed. So same denominator, same denominator. That will then become 2r cubed over 3. And then let me just clean this up. Hang on. This will then become minus r squared r minus h. And then this will become a positive r minus h cubed over 3. So now it's just a matter of cleaning this up. This times this, that will then become pi 2r cubed over 3. This times this will be minus r cubed. This times this will be plus r squared h. And then you've got this ugly thing here later on. We would deal with this, r minus h to the power 3 over 3. We can tidy this up. Well, let's imagine this as being over 3 over 3. So that's that will then become, so hang on, v equals pi, this will then become minus r cubed over 3, merging these two together. And then let's leave this alone, plus r squared h, and then plus. Now multiply this out now. So multiplying this out, it will be, use whichever method you want. I'm going to use Pascal's triangle. So whether to, so remember cubed is kind of complicated. So the coefficients will be 1, 3, 3, 1. So I'm just multiplying this out now. So it will be 1r cubed, and I'm expecting you to be able to do this, plus first coefficient, well, second coefficient will be 3, and then the r goes down by 1 squared, the h goes up by 1, and then next coefficient will be 3, the r goes down by 1, the h goes up by 1, minus h squared, and the last coefficient is 1, this thing cubed. Okay, so now let me think. Now now so that will be V equals pi, and then this thing here. Oh, let's just tidy this thing up for the time being. So r cubed over 3 plus r squared h. Let's just clean this thing up. This thing here will be plus r cubed, and then minus, hang on, let me extend this. This thing here would be minus, because of that h there. So that would be minus 3r squared h. And then this thing here would be plus, because negative h squared, plus 3r h squared. This thing here would be minus h to the power 3 all over 3. And then now hang on. Now merge these two together. Same denominator, same denominator. This would cancel out. This would cancel out with this. So that would then become that's r h, and then plus, and then our complicated thing here over 3. These two would cancel each other out. What else would cancel out? You've got hang on. You've got this thing here, minus 3r squared h plus 3r h squared minus h to the power 3. Let's turn this into a fraction, 3 over 3, and then you can see same denominator, so you can merge these two together. So this would cancel out with this. So that would then give us pi. Remember, this would cancel out with this. That would then give us 3rh squared minus h to the power 3 over 3. So this is our final formula for a given h. The volume is given by this. Okay.